All right, folks. A very warm welcome to Effortless Platform Engineering multi-cluster Valkey Deployments with k0rdent. My name is Prithvi Raj. I apologize for not being there in person. I had some visa issues last moment, so I couldn't make it. And then obviously some issues with Zoom and Gmeet. But finally, we all are here, and a very warm welcome once again to the talk. I hope the conference has been going well for you. To quickly introduce myself, my name is Prithvi Raj. I am based out of Bangalore, India. I'm a CNCF ambassador. I am currently working as a community manager for the k0s and k0rdent projects. I used to do a lot of chaos engineering for the first 4 years of my career, and I helped build the Litmus Chaos project. But right now, I'm focused on k0s, k0rdent, and OpenSDN. These are my socials, and obviously, you can also find me on Slack, where I am available on the Valkey Slack, the CNCF Kubernetes Slack. I'm also a co-organizer to KCD Bangalore. So folks who are visiting India or visit any of the meetups in Bangalore, feel free to find me or drop by. So on the agenda, I guess we'll find out what's there, what we are going to talk about. But let's be sure that we are going to be talking about platform engineering, how the ecosystem has been until now, what's Valkey's role in the platform engineering ecosystem, what's k0rdent. I think a lot of folks know what k0rdent is. People are still understanding the k0rdent tool itself. So we'll dive deeper into k0rdent, how it's streamlining multi-cluster Kubernetes operations. And then by the end of it, we'll try to cover some slides around the demo. My demo environment was breaking before this talk, so I thought that I'll put down some slides according to what we have already done with Valkey and k0rdent. So that's in store for you. So let's be sure we are going to be talking about the amalgamation of two popular projects or two important projects that are k0rdent and Valkey. If I have to talk about what the ecosystem currently looks like, since the inception of Valkey, a lot of platform engineers have been moving to an open sourcey sort of ecosystem where people are using their CI/CD deployments, Valkey, and say a cluster API together. But we have just tried to, renovate or reinvent the idea behind it, and that's where we came up with this idea of deploying Valkey with k0rdent for your distributed container applications. So going back to what we were initially supposed to discuss, let's start with the start. How cloud emerged and what was supposed to happen and why we came up with something called k0rdent. Obviously, when cloud computing came up, say around 20 years ago, the idea was pretty simple. Consume infrastructure as a service, everything would be easy. There's a data center, there's cloud, just simple interaction. But come to today, we are served with so many layers of APIs under the hood. There are so many different services. People are using public cloud environments, hybrid cloud environments, multi-cloud environments. So cloud in itself has become complex, where now currently we have the battle for control between proprietary stacks, multiple cloud vendors, and people are struggling to navigate through it. And that is where container orchestrators came in to try to make this journey simpler. You talk about Kubernetes or Docker Swarm, Apache Mesos. All of this came in to make things simpler and basically ensure that there is some standardization between these cloud providers. And Kubernetes in itself has matured today. I think people who attended the Open Source Summit or have been attending KubeCons, they have heard a lot about what's happening in the Kubernetes ecosystem. Today, Kubernetes is being driven not just by APIs or other tools under the hood. If you see the CNCF landscape in itself, you need a magnifying glass to magnify onto the tools that are available today. But Kubernetes, obviously, it has provided an open standard, simplified solution of how You can use your cloud or environments or infrastructures, and how you can run them to satisfy your use cases. And let's make no mistake, I mean, Kubernetes, I see it as a powerful scheduler. It can act as a common control plane between all your data centers and all your cloud, multi-cloud, hybrid cloud environments, where a thin layer of Kubernetes basically helps you use your cloud services, infrastructures, and Kubernetes has turned into a platform itself to support your workloads. Even if there's a shift towards AI or GPUs, Kubernetes is being used as the main control plane here. And that is where, we shift our discussion towards platform engineering, the idea of platforms, and why we came up with k0rdent and how it's helping the Valkey community today. I mean, as you know, the idea behind platform engineering was to enhance what DevOps did, or the challenges that DevOps provided, to conquer them, to try to create an ecosystem where you're building, not just focusing on, say, building different solutions, but you're treating platform as a product itself. So the idea was creating or standardizing an approach to create internal developer platforms and streamline software delivery. I mean, today, if you have to talk about software delivery in itself, it's not just your CI/CD, but it's also different other aspects to your infrastructure. That's your resiliency, your feature flags, your cloud cost management, your SRE, SLO, SLI practices. So basically, it's abstracting complexity and making sure that I believe a lot of folks who are attending this conference are developers. And the idea was to simplify what developers do today, and they are able to focus on code and ensure efficiency rather than, wasting their time or spending a lot of time in learning new tools. So if I have to talk about how things were before DevOps, I mean, obviously there was a lot of manual ticketing, IT, software delivery was slow. But in spite of DevOps being there, developers are asked to learn a lot of new things. I mean, developers are asked to learn Redis, developers are asked to learn Valkey, how things are different in terms of licensing, how things are different in terms of different tools. Developers are asked to learn chaos engineering, new tools, incident management. So in spite of DevOps being there, I agree that software delivery sped up a lot, but developers have experienced suffering. They don't want to learn about new things or infra, and there's a lot of cognitive overload and developer burnout to learn these new tools and implement them, and that takes time, that costs money, and eventually there's low developer productivity and onboarding. But that is where platform engineering as a discipline came up to build, maintain, and bring up new internal developer platforms, which became a prominent layer. If you have to talk about under the layer of software deliveries, platform engineering has become that layer which is helping deliver software faster, secure, and in a more, like automated, compliant manner. And if you have to think of, an internal developer platform or an IDP, it's a developer's cockpit. If a developer is a pilot flying the jet of software, it's his or her cockpit, where you are able to pre-configure, and you are able to bring in your CI/CD pipelines, your security gates, provisioning, observability stack, and other knowledges around your underlying systems. And that has improved interaction. Now platform as a product has developed. It has, I don't believe it's a new concept. I mean, platform engineering has existed always. Earlier it was maybe packaged at DevOps, and today people are suggesting that DevOps is not existent or it's dying, but that's not true. I disagree to that. But platform engineering in itself has helped you integrate different tools, where infrastructure is becoming something that not just your customers eventually enjoy, but your developers or your different developer teams are enjoying with their collaboration and standardization in place. And what are the top reasons to consider platform engineering? I know there's a lot of theoretical stuff here, but I mean, Platform production releases are happening once a month. You have to accelerate your journey. We are moving from manual tasks, costly tasks. Yeah, you want to utilize your resources well. And I mean, incidents, downtimes, all of this is causing a lot of hurt for developers and organizations in its place. And today teams need I mean, platform teams need certain aspects to, overcome the challenges that implementation of platform engineering brings in itself. You developer is self-service. You need to accelerate your app deployments, provision their resources in the right way. Your operational simplicity, of course, you need to streamline your complex deployments across multiple clusters, different locations. Even if, say, you are deploying your key value pairs, you need to ensure that they are multi-tenant and there's visibility and control. You're able to continuously monitor them. It's secure and compliant. I mean, in Europe itself, there's a lot of talk about DORA compliance and how you need to implement that. So platform teams need these aspects to ensure that they are building the right platforms. And today, as I spoke about initially, that platform engineers are looking for multi-cluster configurations, while creating IDPs. Platform engineers need to be able to manage their multi-cluster environments. They have their AI/ML environments, their edge IoT platforms. They have to be highly available in nature so that the fault tolerance is improved. They are able to run your workloads across clusters in multiple regions. You need to maintain isolation from different teams and data sovereignty. As I spoke about, there are country specific rules and people need to comply with them. So while ensuring that you have your multi clusters in place, you also need to ensure that you are able to manage them well. And platforms need to be democratic. If I have to be honest, I mean, platform engineering has evolved through multiple stages, but there has to be, like, I mean, if there is like a rigid separation between operations and developer teams, we need to ensure that we are addressing this with the concept of a platform group, or say emphasize that even if there are different teams in place, they all are involved in the decision making. So your platform group, your data team, your different stakeholders who are involved in, and including your external stakeholders, are involved in making your platforms democratic and ensuring that the producers and the consumers of these platforms are not just specifically your platform engineering teams, but it's also involving, say, your developer teams, your DevOps teams, your SRE teams, your QA teams, everyone, and eventually your customers or end users as well, to make these platforms democratic in nature. I won't take much time to cover this because I think we believe, we all know that infrastructure as code has been playing a foundational role in driving platforms, and obviously it's acting as a critical enabler to automate, scale, and ensure that your platforms are consistent in nature. So eventually, I would like to conclude what we started off. Like, Kubernetes is acting as an orchestrator, or helps becoming that layer which is helping make your cloud or edge environments declarative in nature, more extensible, API driven. You are able to integrate it with your AI/ML pipelines. And as platform engineering evolves, Kubernetes ensures that you're providing consistent programmable substrate to power your IDPs and enable them to be secure, resilient, and compliant to the current ecosystem. So with this, I mean, we'll move to what we were going to talk about. Obviously, we talked a little bit about platform engineering and how Kubernetes is driving it, how platform engineers are becoming more and more, relevant, and how platform engineering in itself is becoming more relevant to each ecosystem. Some people see it as a niche, but today I believe it's the talk of the town. And with this, we'll cover how Valkey is playing a crucial role in the platform engineering ecosystem. I mean, mean, if I have to talk about Valkey in the platform use case, it has multiple people use Valkey according to their needs. But if I have to, I believe everyone is aware of what Valkey is. So I'm not spending some time explaining what Valkey is. But some common platform use cases that Valkey is driving is reading and caching sidecar shared caches, say for API and microservices, query result caching, full page fragment caching. This is like a classic speed layer. You need to ensure that in your databases or your frontline services, you are able to use Valkey clients running on different Kubernetes environments. Again, your session, as I spoke about, feature flags, it's an important aspect of building tools today or your software delivery process today. So you're using Valkey for your session storage or feature flagging, your ephemeral values, eviction policies. For a rate limiting as well, you are using counters or token buckets, often using Lua pipelines to keep your app operations atomic in nature. Lightweight queues and streams, you use list streams for work dispatch, pubs up for your fan out notifications, where Kafka would become an overkill. And obviously, your coordination primitives like, say, short lived logs, leader election for jobs and controllers, your TTLs, and eventually edge or tiered caching for your per cluster, per Valkey, close to workloads, latency, designed for locality. These are some prominent Valkey platform use cases that we are seeing in the ecosystem today and that we have noticed as a community while being open with K0s or k0rdent. And there are your day two platforms concerns as well. Once you are able to build your platform, once your platform engineering teams are in place, there are some concerns that the community is facing in terms of durability, say for your use cases for pure caching, go memory with eviction, for QQs, critical coordination, to enable your test failover, rehydration. From a topology and HA perspective, say, spreading master replicas across zones, enforcing pod disruption budgets, test rolling and resharding, Helm values, or your ACLs, passwords via Kubernetes secrets, mandatory TLS in transit, and eventually your cost controls as well. I mean, memory is the driver. You need your right size shards. You need to, ensure that your max memory policies are in place, and you need to avoid your large blobs. So, the day two platform concerns in itself, I believe Valkey comes into place. It's used as a best practice to call out your connect limitations, size them according to your correct resources, your Kubernetes clients. So that is where we have seen as a community Valkey being utilized the most. That's come as a feedback from the community. And moving back to what we were talking about, I mean, we spoke about the common platform use cases and day to platform concerns, but teams are looking at like an open source governed, compatible, cache KV store compatible. They can run it anywhere in the platforms. And I believe Valkey provides that clarity, that licensing clarity, community governance, the performance in itself, where people have been shifting to its usage and using it more and more uh, in terms of their Kubernetes environments in itself. So with this, we'll talk a little bit about the challenges of multi-cluster platform engineering and why we are trying to use Valkey here with k0rdent. I mean, today, currently, obviously, people believe that there has to be a single application per cluster. There are multiple infra providers in itself, and the clusters in itself are dynamic in nature. You are having multiple beachhead services running alongside it. There's a Kubernetes sprawl, so your workloads are inconsistent in nature. There are risks of non-compliance, management complexity, policies are not in place. And what were your options for multi-cluster platform engineering, if I have to say so? I mean, multi-cluster platform engineering isn't simple. Organizations are, I mean, given multiple choices, you might not end up doing anything. You just, ensure that your infras are running in a multi-tenant in a separated way, so your infra and ops costs keep growing. There's barriers to developer productivity, or people who have already started implementing the DIY open source, which is a cluster API. So people are using different cluster API providers. There's a huge learning curve, of course, operational burden, and it's hard to extend in your on-prem or public cloud, from on-prem to public cloud environments. And then comes proprietary solutions. I mean, there's Terraform, Rancher, there's licensing issues, bundled requirements, hard to extend. And eventually, learning this in the ecosystem, what's happening, people are also looking towards a cost-friendly solution, which is basically, following some FinOps guidelines. There's your state management, there's your cluster management for different cloud providers. And that is where we thought of coming up with something unique for the community, and that is Cordant. The biggest hurdle was obviously inconsistent cluster provisioning, and that is where Cordant was designed as a super control plane to ensure that you are able to manage your different clusters, different environments in an easier way. And Cordant acts as that super control plane with its management cluster to manage your different services across clusters, across cloud. So it's a multi-cluster, multi-cloud management tool. And obviously Cordant is scaling and helping manage its uh, it follows an approach where you are able to manage your clusters and deploy and update them according to the new beachhead services that start running. So say you want to add an incident management tool, say you want to add some feature flagging, all of it you are able to manage with Cordant, ensuring that you are controlling costs and obviously security and reliability in place. The key design approach that we have taken is it follows a templated approach. So that's the best part. So you are basically uh, using a template, which is a YAML file, to bring in your services for your clusters or for your state management or for your FinOps, metrics logging side of things. And that is where we believe that Cordant is the current generation of Kubernetes evolution, where it started off with early adoption, and then we moved to OpenShift and heavyweight packaged Kubernetes for enterprises. Then came lightweight Kubernetes with K3s and kubeadm and the other stuff. And then obviously people moved on to K0s and maybe looked for a hosted control plane. A control plane in itself is commoditized today because of the heavy usage of cluster API. And then Kubernetes, as I spoke about, is a powerful scheduler, the orchestrator of the future. And that is where we came up with Cordant, which is open source, API driven, and follows a templated approach. So I think I have explained Cordant pretty well. The benefits that it provides for platform engineers is it's simplifying multi-cluster operations, it's enhancing developer experience, and it's also providing an automated, scalable way of managing your different Kubernetes environments. So at its core, I mean, Cordant has three subcomponents. One is the Cordant Cluster Manager, which is helping you basically provision your clusters, manage the life cycle of it. It uses cluster API under the hood, and it is also using Cosmotron to basically help your hosted control planes. For the second component is your state manager, which is built on another popular open source tool called Swelltoss. So basically, you are able to manage or provision the life cycle of the different Kubernetes services that you're running, say your ingress controllers, your MongoDB, your different controllers, add-on controllers that you're using alongside your Kubernetes infra. And that is where I believe that Valkey comes in and its template is brought up to use a Valkey operator alongside Cordant, and then there's your observability and FinOps, which is using OpenCost and Victoria metrics under the hood, where you are able to visualize what's happening in your systems. You are able to ensure that you are reducing your costs while building your Kubernetes infra or running different clusters and provisioning them. So this is the overview of the architecture: your cluster manager, your state manager, and your KOF, observability and FinOps. These are the three main subcomponents of Cordant, and this is what we are using under the hood. Just like Valkey is completely open source, the idea that we had was to ensure that Cordant is completely open source as well. So we are using k0s, Cluster API, Cosmotron, Sweltos, Grafana, OpenCost, OpenTelemetry under the hood. So now we will cover how Valkey is can be used to deploy with Cordant. And one of the most interesting aspects that I was going around was the Valkey bundle, which came out earlier this year, where the idea was again the same: to enhance developer productivity, ease access, and that is where say while you are using your applications or building them, what are the four key aspects to it? Your JSON, your Bloom filter, your vector search, and your LDAP applications. So the idea was to set up a single container deployment and simplify it for your CI/CD pipelines while maintaining, consistency across your production environments. And that is where it becomes easier to deploy it with Cordant, because Cordant again acts as the mothership or the management cluster. And then you are deploying a Valkey operator as a Valkey bundle, which consists of your JSON, Bloom, your vector search, and LDAP. And that is deployed as a child cluster into your Kubernetes infra. So again, and for this, you are using your command line itself, because it doesn't have a UI currently. I mean, there's a UI which you can pull in, or you build in your own UI, and you can use Cordant alongside, and then you can deploy this management cluster, and then you can deploy the Valkey operator as a child cluster. But the Valkey bundle in itself being deployed with Cordant helps you manage your applications in a more simpler way, and that is the main use case that I have seen or visualized with with Cordant and Valkey working hand in hand. And if I have to talk about the architecture, I'll talk about how Valkey fits into the Cordant architecture. But this is what the architecture looks like, and this is how we have built it together, and it fits into the different layers of platform engineering. And we are using predefined service templates. As I spoke about, it follows a templated approach. So the idea is that these templates basically have different aspects to it. Like you are if you check the catalog, it has an API version. You're using your kind clusters. You can obviously pull it in using a Helm chart or some kubectl commands, but it's easier to pull it using a Bitnami Helm chart. So you have some metadata, you have some cluster spec, and then your service spec, which is what services are you running. So there are different templates that are already available for certificate management, ingress controller, backup and disaster recovery, security and policy enforcement. So there are different catalogs that are already available. And that is where I am taking you through one example of a service template, which is Cordant's state manager service template, and it is defined and how it's run. So as I say, you can deploy it using a Helm chart or raw Kubernetes manifests. The configuration, you can add your template values, your version, your spec, which chart you are trying to use. You have your health management in place as well, so that you can integrate it with your monitoring tools. So you want to integrate a Grafana dashboard with your cluster deployment where a Valkey operator is also running. So service templates can be used in two ways. Either you can deploy it via cluster deployment or as a multi-cluster service. And here we will be deploying it using a multi-cluster service. So as I spoke about, this is the k0rdent catalog, and this is how it looks. It provides you choices of different applications. And that is where Valkey is a template on the k0rdent catalog. So as I mean, we have defined what Valkey is. It becomes very easy to pull in. So it's basically a marketplace. So once you have k0rdent up and running, you can easily access the Valkey operator or Valkey template from the k0rdent catalog in itself. For once you have already matured and you're trying to build your data structure. So what are the prerequisites? I mean, this is something that you can start off for the demo. You have your client cluster handy. You deploy your cluster API provider for Docker, which is your kbd, and then you use the Hyperspike Valkey operator to manage your Valkey instances. While we are using Docker and kind for simplicity, k0rdent supports any KAPI provider and can run on any Kubernetes distribution for your production deployments. And then you start off with setting up your management cluster. So once you are done with setting this up, you start with setting up k0rdent in itself. Again, as I spoke about, you can pull in k0rdent using a Helm chart or a kubectl. Obviously, as a prerequisite, you'll need your Docker running as a daemon set. You'll need your kind kubectl and Helm CLI is up. And then once that is done, you set up your management cluster by creating a new kind cluster mounted on a Docker socket. After the kind CLI finishes getting up, you install k0rdent into your new cluster, and then you install the Valkey service template, which again I spoke about in the k0rdent catalog itself. You install the template to k0rdent using a Helm chart, and you once you have done that, you set up your credentials. So you are setting up a group of credentials for your kbd provider to work. You're setting up your metadata, and you set up the namespace, the labels, the API version, and then you add these details, and then you start creating your child cluster, which is your Valkey operator, which we are setting up in a hosted control plane. As I spoke about, once you are done with setting up your credentials, you set up your child cluster. So what you do is, obviously you use you're putting up your metadata and your kind, and you should note that you're using the Docker hosted CP100 as the template for the new child cluster. That will help you use kbd, the kbd based child cluster in a hosted control plane. And that's again a USP about k0rdent, which you do not find, say, with a cluster API or any other tools that are out there. And once you are done verifying the child cluster, you are ready to set up for your Valkey application delivery. That is basically set up the storage provider in the child cluster with your local path. You should wait until the child clusters are up and running, and feel free to exit when the pods are ready. And then you deploy Valkey using a multi-cluster service. As I spoke about, we are deploying Valkey using a multi-cluster service. So first up, obviously when there's a lot of YAML, you're confused and you need to ensure that k0rdent is simplifying. They are deploying Valkey in a child cluster. So you are ensuring that you add the label to the child cluster in the management cluster where k0rdent is running. The label is, let's say, is group demo, and the label is needed because we are using a multi-cluster service object, right? So you need to ensure it is able to reference to the multiple child clusters for its service delivery. And as we are using a Docker-based cluster, we keep in mind that we are not restricted to the cluster we need for our services. It can be a single child cluster, or you can group them, and eventually you verify if your service is running or no. So if you start running Cordant, you see that there are different services running. There's your Cosmotron controller, there's your state manager, which is your Sweltos controller, then there's your local path, obviously your storage. And then once you are done with installing the Valkey operator, you can see that the service is running in itself as a template, and the Valkey operator or the Valkey service is up. So how does it work? This is a template that I created, that you have a management cluster that runs Cordant, Flux. Again, Cordant, as you saw before, one of the open source tools it's using under the hood is Flux and Cluster API. From there, you are pushing your Valkey operator into, say, a child cluster or different state services workload clusters, which we have listed as say environment prod. Once the operator is present in the workload clusters, you declare a Valkey cluster custom resource in the own namespace, and then those operators turns it into real Valkey clusters, that stateful set, services, PVCs, PDBs. So that is how I have created this diagram. Apologies, I gave some prompt to chat GPT, and there's some issues that has come up with the arrows. But this is how, like, if you see the management cluster, it is hosting the Valkey operator service template. Then it is also hosting the multi-cluster service, which is your Valkey operator fleet. And your cluster selector is your environment prod, as we spoke about. From the Flux side of things, you are using your per cluster and your Bitnami operator, and then your cluster API, which is basically your CAPD. That's again part of the management cluster itself. And from the workload cluster, each workload cluster, obviously, it has the same layout. It's using a Valkey system namespace right now. The Valkey operator is running your CRDs, your controller deployments, and it is watching your Valkey operator CR, but your different namespaces that are the stateful sets, the services, the PVCs, and the PDB, they are being managed by the Valkey operator CR itself. So as I spoke about, moving back to why we spoke about this and how it's essential, is because it's helping platform teams, and how Valkey is driving a platform engineering use case. Again, fleet-wide consistency, there's clear tenancy in nature, your guardrails, you can enforce your chart values, your TLS, your auth, your existing secret storage classes, and you can upgrade it without a drama, because it's following a service template approach. You just need to ensure that you're making the right changes to the template, and you are making the changes even if you have to upgrade the versions of Cordant or, say, your Valkey itself. So before I conclude, this is where we have brought in Valkey. So this is an example of an internal developer platform where you're using your complex, Cordant cluster manager to manage your clusters. Say they are hosted on Linkerd, your service mesh, your infrastructure itself. You are using the monitoring, logging, tracing tools, Fluentd, OpenTel, Prometheus, Jaeger with Cordant. And again, from a service management standpoint, you are using Valkey for your key value data pairs, and you are running Valkey as a beachhead service using Cordant, which becomes very easier with the templated approach. And then obviously, if you want to build a developer platform, you can use Backstage, or you can use other IDPs, IDP aggregators out there with Cordant, so that you are able to run them in a pretty easier way. So with this, it's time to go. Feel free to play around with the Valkey operator by leveraging a multi-cluster service using your Helm charts, and you can even if you're not using a kind cluster or in your Kubernetes environments itself, you can use k0rdent to em- basically use the power of Valkey in your infrastructures in itself. And last up, here you check out k0rdent. This is the QR to scan and check out k0rdent on GitHub. And thank you so much for tuning in. Apologies again for not joining you live, but it was great to see the traction towards Valkey and its amazing community driven by Kyle and all the other folks involved. Thank you so much.